Everyone, imagine if fire protection pipes were installed incorrectly so that during a fire the water flow could not reach the point of ignition. What would be the consequences? Today, we are going to unlock the code of fire water supply and drainage construction drawings. That is, learn how to interpret these drawings. Water supply and drainage construction drawings serve as the bridge between engineering design and construction. They use graphical language to express design intent and to guide on-site operations. By systematically analyzing the reading methods, we ensure that every pipe and every valve installed is placed precisely according to design. These construction drawings are composed of two parts: basic drawings and detailed drawings. Basic drawings include layout plans, sectional views, and axonometric drawings that present an overall view of the system. Detailed drawings elaborate on key nodes such as pipe connections and equipment installations. When reading these drawings, you must first grasp the overall layout before examining the details in order to establish a solid spatial logic. There are 4 key points to note when interpreting the drawings. 1. For interior water supply construction drawings, first compare them with the drawing index. Verify that the entire set of drawings is complete and that each drawing's title matches what is listed in the index. Only after confirming this should you proceed with a detailed reading. 2. During interpretation, it is essential to clearly distinguish between different systems. Do not mix them up. Compare the layout plans with the system diagrams so that they complement and explain each other, thereby building a comprehensive, complete, and detailed engineering image to fully grasp the design intent. If you are unsure about installation dimensions, requirements, or connection methods for water-using equipment, refer to the corresponding detailed installation drawings. 3. For the water supply system, follow the incoming water flow. Begin with the system's entry point and read the drawings in sequence. From the inlet pipe, the main trunk pipe, the branch pipes, and finally to the water inlet connections of the equipment. 4. For the drainage system, follow the direction of drainage flow. Start at the outlet of the water-using equipment, and then proceed through the drainage branch pipes, the main drainage pipes, the vertical drainage risers, and finally, to the discharge pipes. Next, let us continue with the general provisions for reading drainage construction drawings. The lines on the drawings should be clear and accurate, and different types of pipes and equipment must be represented using distinct line styles. The scale of the drawings should be appropriate, detailed enough to show critical features while still presenting an overall view of the project. In addition to scale and line types, there are 2 other key elements to pay special attention to. First, the elevation. This element determines the installation heights of pipes and equipment, and it must be marked accurately. Elevation is typically expressed in meters, m, and recorded to 3 decimal places. For pressure pipelines, the elevation is usually given at the pipe center, whereas for gravity pipelines, the bottom internal elevation is often marked. For indoor projects, relative elevations are indicated. For outdoor projects, absolute elevations should be provided. In the absence of absolute elevation data, relative elevations may be used. Second, the pipe diameter. Clearly marking pipe diameters is essential as it directly impacts pipe selection and performance. Pipe diameters are expressed in millimeters, m. In water supply systems, each inlet pipe is considered an individual system, while in drainage systems, each discharge pipe or outdoor inspection well is treated as a separate system. When there are multiple pipes or pieces of equipment, they should be numbered to facilitate identification and management. Becoming familiar with and mastering the drawing legends is fundamental to accurately understanding the content of the drawings. Next, We will delve into a detailed explanation of the fire water supply and drainage construction drawings. These drawings are composed of several parts, from the drawing index to the overall design and construction instructions, and then to the main equipment and materials schedule. Each part contains critical information. The layout plans and system diagrams are essential for understanding system configurations, while detailed drawings offer specific guidance on construction. The drawing index arranges all construction drawings by number and title in a tabular format, which facilitates both the verification of the complete set and the location of individual drawings. Think of the drawing index as the map of the construction drawings. In a complete fire protection system, you should have a layout plan, a system diagram, and detailed drawings. Any missing parts must be added immediately. The general design and construction instructions act as the navigator for the project. They include the project overview, design requirements, construction specifications, the main equipment and materials schedule, and special notes on issues demanding particular attention. Every sentence in the design instructions could potentially affect the construction. For example, if the pipe material does not have sufficient pressure resistance, a pressure test might cause a pipe to burst, resulting in rework. The main equipment and materials schedule functions as the bill of materials for the project, clearly listing the categories, quantities, specifications, and key dimensions of the major materials and equipment used. The layout plans and system diagrams serve as the roadmap for construction. The floor plan is the most fundamental type of construction drawing. The layout plan shows the positioning of water supply and drainage, as well as fire water supply pipes, sanitary fixtures, and other water-using devices, while the system diagram illustrates the spatial arrangement and interrelationships of the pipes. The overall picture of the project can be understood through the system diagram. For instance, in high-rise buildings with fire hydrant systems, a layout plan shows the horizontal locations of the hydrants, whereas a system diagram reveals the vertical routing of the risers. Detailed drawings then provide the exact structural details and installation requirements of the equipment and pipes, including their placement, connection methods, routing, slopes, and diameters. Reading fire water supply and drainage construction drawings requires the cultivation of systemic thinking. First, understand the overall picture, then focus on the details. It is recommended to proceed in 3 steps. First, read through the drawing index to confirm the completeness of the drawings. Second, analyze each system separately. Read the water supply and drainage drawings independently. Third, verify on-site by comparing the drawings with the actual installation to avoid misinterpretation. Overall, reading construction drawings is an essential skill. I hope that you will master the methods for interpreting fire water supply and drainage construction drawings, not merely being able to read the drawings, but also understanding the underlying design philosophy and construction requirements. Build a solid foundation now so that you can reap the benefits in actual projects in the future. Remember, practice is the only criterion for testing truth. By participating in real projects, you transform theoretical knowledge into practical skills.